In this lecture, we are going to write a program to find the sum of infinite series that is available here in the screen. Now this is an infinite series. We are going to find the sum up to certain terms. Let's say we are going to go up to n terms and find the sum and try to approximate the value of this entire series up to certain number of terms. Let's assume that there are n number of terms that is being provided by the user. So if we have to write down a function for this, what would be the name of the function? The first thing that we need to discuss is what would be the name of the function. So let's say the name of the function is infinite series. Okay, let's name it as infinite series. Now what would be the return type of this function? Okay, whenever you are going to write a function, think in terms of return type. What does this function actually return back to whoever calls it? So this function will find the sum of this series and return back this sum, right? So let's say the return type, because the sum can be any double value, because I'm actually adding half plus 1 by 4 plus 1 by 8. So I'm adding all fractional numbers. So my answer can be any floating point value. So let's assume that it returns a double value. Okay, it returns a double value. And what would be the input for this function? Let's say if I am the function to find out the sum of this infinite series, what is the input that I will be needing in order to find the sum of the infinite series? I'll be needing how many terms are there in this series, right? So number of terms is the input. So input is nothing but number of terms, okay? As number of terms is an integer number, so I can have int n as my argument in a function. So we have given the outline of the function. Now let's write down our function to find the sum of infinite series. So first of all, I'll start with the return type. Return type is double. Okay, double is the return type. Name of the function, as you have already decided, is infinite series. Now I have to open the parenthesis and I'll have to provide the input or the argument. So in this case, my argument is number of terms. So I'm assuming that number of terms is n. So I write int n. Okay, and then I hit enter and open the brace and close it. So this is my function. Okay, so it has the return type of double. The name of the function is infinite series and it takes one argument, that is the number of terms, right? So what I'm trying to do is, because I cannot actually find the sum of infinite series, my loop would go for infinite number of times, right? I don't want that. I want sum up to certain number of terms. So in this series, if you see, I'm actually doing 1 by 2, that is 2 to the power 1, plus 1 by 4 is 1 by 2 to the power 2, 1 by 8 is nothing but 1 by 2 to the power 3, and it keeps on going up to infinite. Okay, now I can't do the sum up to infinite because I have to find a value, approximate value for this term. Okay, let's say I go up to n terms. If I go up to n terms, this is the first term, right? So first term I have 2 to the power 1, second term I have 1 by 2 to the power 2. So in the nth term I'll be having 1 by 2 to the power n. So what I'm trying to do is I'm trying to find the sum up to n terms, and this n would be provided to me by the user. N can be anything. N can be 5, n can be 10, n can be 100. Okay, I would get a more approximate answer if n is absolutely large. So if n tends to infinity, I'll get more accurate version of my answer. Okay, but practically it can't be infinity in case of the demonstration here. So we'll try to make sure that n is as large as possible, and we'll try to check the answer for that. So now let's try to code this. Okay, so here I'll have to run a loop starting from I equals to 1 to I equals to n. So I'll have to have a variable I that will run a loop from I equals to 1 to I equals to n. Let's put this in our code. So my loop will run from I equals to 1 to n. Okay, so I can initialize I here, int I. Okay, and then what I do is I'll have to run a loop for I initially is 1. Okay, I is less than equals to n, it goes up to n, I plus plus. Okay, so this loop runs for n time. Let's assume that this sum would be stored in the variable sum. So I'll declare sum to be double, and let me initially make the sum as 0. Okay, and I'll keep on adding each term to my sum as and when that term is encountered. Okay, so how do I know what is my term? Let each term be stored in a variable term. So I'll just write a term variable here. Okay, now how do I get each term? Okay, so my term variable would be, term is nothing but it is 1 by 2 to the power I, right? So I'll write pow 2 comma I. So it is actually going to find 2 to the power I. Okay, so it is nothing but each term is 1 divided by 2 to the power I. Whenever I is 3, it is 1 by 2 to the power 3, that is 1 by 8. Okay, so because I'm using pow, I'll have to have a header file has include math.h. Okay, because I'm using the power function. Now the term is calculated. After I calculate the term, I'll have to add this term to my answer. So I'll write my sum, final answer is sum, is equals to previous sum plus the term value. Okay, so each time the term will change in the loop and then it will be added to the sum variable. So finally, once it is done, here my sum is ready. Sum of the series up to n terms is ready. So I'll have to return this sum variable, which is double variable, from this function. Okay, so finally I return the sum variable from this function. So this is called as function definition. So here in function definition, I've defined how does my function, that is infinite series, really works. It will take one argument, that is the number of terms, integer value. It will do some processing. I'm running a loop here which will find out each term, and then that term is added to my variable sum, and finally sum is returned back from this function. This is how the processing happens. Okay, at line number 25, I end my function definition. Once the function definition is done, I'll have to write a main function from where I'm going to call to this function and make use of this function. Okay, so let me write the main function here. Okay, this is my main function. So here let me have one variable, n variable, which is my number of terms. So I'll ask the user to enter the number of terms. So number of terms is now scanned from the user. Okay, now I'll have to find the answer. Let's store the answer here in the variable ans, which is a double type. Okay, so I'll have a call to the function called as infinite series. So the name of the function is infinite series. Okay, and what do I pass is n, which is my number of terms. Okay, now it will make a call to this function infinite series. That is, the control will now be transferred to line number 13 and it will do the calculation, and at line number 24 it will return back the sum. So I'll have to capture that sum and store it in the variable ans. Okay, and then finally I'll display the answer. So I'll write answer is equals to %lf because double format specifier is %lf. Okay, so now I'll write ans here. So now I think this should work fine. Let's try to test this first, and then we're going to discuss this in more details. Okay, so if you see here, name of the function here is prime function.c, which is not the correct name because this is the program to find the sum of series, right? So I can go and change the name of the function. I can right click on the function name or the file name and then rename it. I'll just write this is inf series.c. Okay, so this is renamed now. So I'll now compile it, gcc inf series.c. So after I compile, I see a lot of warnings in my program. So it is saying that stdio.h is not provided, right? Because I'm using printf, so I'll have to also have the header file has include stdio.h in my program. Okay, stdio.h. So now let's save this. Let me compile this one more time. Still I have some error here. So it is saying that implicit declaration of function infinite series. Okay, so maybe I've done some mistake in the spelling of this particular function. So wherever I'm calling it here, it should be the same name. So I'll just paste it here as it is from there. Okay, so I've corrected the name of the function because it should be the exact name as it is being defined. Okay, so now the error is gone. So now I can run this code. Okay. Let's provide number of terms as 3. I get 0.875 as the answer. Let's provide number of terms as 5. Okay, if I have 5, I'll get more approximate answer, that is 0.968. If number of terms are 7, 0.992. If it is 10, it is 0.999. As in when you provide larger values of n, the sum would be closer to 1. Okay, so the sum would actually approximate to 1 because sum of this infinite series is 1. Okay, so this is working fine. Now you may be wondering, in both my main function as well as in my function infinite series, I am having this variable n, right? Now these are two different variables. They are not the same variable. I'll explain this. Okay, so whenever you are in the main function, you have written down in line number 30 that there is an integer variable n. So it will reserve a box for you, a storage unit for you, wherein it can write or store the integer value. Now this belongs to the main function. This storage belongs to the main function. So none of the other function can have the access to this variable n. Similarly, this n in the infinite series function is local to this infinite series function, meaning no one else can have access of this variable n. So this is again one more variable, but this belongs to the infinite series. Generally in a program you can't have two variables with the same name, right? But they are actually different variables. This variable is local to the main function, okay, and this variable n is local to the infinite series function. So they are not related, okay? So now whenever you actually take the input from the user, let's say input is 3, user presses the number 3 and this is scanf, okay? So this n becomes 3, and whenever you call this infinite series, this is a function call, right? Whenever you write infinite series n, so 3 is the argument of this, so this will be passed to this one, okay? As of now this n is having some garbage value, okay? As and when the function call happens, this n would now be initialized to 3, so this garbage will be replaced by 3. So it is actually copying this 3 value to this variable n, which is in the function infinite series, okay? And then it does the processing. It will find out this sum. So let's say the sum it calculates is 0.87 something, okay, approximate value. And once it finds return sum, this will be returned back here, okay? And then this will be stored in the variable answer. So answer would be a copy of sum, but they are different actually. They are different variables, okay? So this is 0.875, whatever it is. And then the answer 875 is displayed to the user, okay? So just note that whenever you are declaring a variable inside a function, that variable would be local to that function. That means only that function can have the access to that variable and none of other function can have the access to that variable. Let's say here I've got the variable term and sum. These two variables are not accessible in the main function. Similarly, this ans variable is not accessible in the infinite series function, right? So if you want to make things accessible, you have to make a global variable, okay, which we will be discussing in our subsequent lectures. Now before we end this lecture, let's learn one more very important concept. Let's say that the function to find the infinite series, I'll place it after the main function, and let's see what happens if I do that, okay? Let me place this function. I'll just copy this entire function and place it after the main function, okay? So I've done no other changes. I just save this and then let me try to compile this code and let's see what happens if it works well or not, okay? So let's try to compile this. So it says that, there is an error, okay? It says that this infinite series is not, there's a conflicting type for it, okay? Implicit declaration for infinite series. Now the problem here actually is, see, always whenever your program runs, your program starts executing from the main function, okay? So it starts executing from line number 14, main function. So it comes down. Here it will see that there is one function called as infinite series. Now the compiler does not know about this function, whether this function is defined there or not, right? How many arguments does this function take? What is the return type? So those things the compiler is not very clear at this point, because my function infinite series function is actually defined after line number 24, right? So compiler does not know here at line number 20 about the infinite series function. So in this case, whenever you are actually defining a function after the main function, that means this is a function call, right? Whenever you are doing a function call before the function definition, in that case, you'll have to let the compiler know that this kind of a function is actually defined after few lines ahead, okay? So for that, you'll have to do something called as forward declaration. You'll have to give the prototype of your function, signature of your function, right? So here, just after the header files, what I do is, I'll just write double and give the name of the function infinite series and then open the parenthesis. And now here you give what is the type of your argument, just the type, okay? So there is one argument of type integer. I can just write int, int, okay? So this is called as signature of the function, or also called as function prototype. So I'm letting the compiler know that, hello compiler, there is one function that is being defined after some time somewhere in my code, okay? That function is named as infinite series. It takes one argument of type integer, okay? And after it does the processing, it will return back the value of type double. So this is called as function prototype. Now you are actually letting the compiler know that something like this function, that is infinite series function, is actually defined after some time. So now if I try to compile this, let's see what happens. So now there is no warning given to me. Okay, so now it works fine. So I can just now give it a run. Okay, so if I give the value 3, I get the value 0.875. If I give 8, I get the value 0.996, and it works fine. Okay, so this is called as function prototype, or you are giving a signature to this function. From the main function, I'm actually doing a function call. I'm actually making a call to this function infinite series. Okay, and this is the definition of function infinite series. But one very important point to note, if you are actually defining your function before the main function, there is no need of prototype. Okay, because you have actually defined the function before the main function, therefore prototype is not required in that case. But if you are defining a function after the main function, you will have to give the prototype at the header section of your code. Okay, but anyways, this is a good practice, programming practice, to always give a prototype for your function. Okay, so in this lecture we have learnt about function prototype, function definition, function call, and about the local variables in the function. That's all in this lecture. Stay tuned.